What's up, Carol Baskin fans? It's Miss Sorensen back at you, video 15, calculating independent probabilities. Let's get started. When two events A and B are independent, the probability of both events occurring is the probability of A times the probability of B. Well, this seems a little bit complicated, but believe it or not, it's not. Basically, when you're trying to find the probability of two independent events, you just multiply their probabilities. So for example, let's say you're trying to find the probability of doing a 5 or rolling a 5 and flipping a heads. Well, completely ignore the second probability. Let's just focus on the probability of rolling a 5. Well, there's 1 5 out of 6. So the probability of rolling a 5 is a 1 out of 6. Now we focus on what's the probability of flipping a heads. Well, there's 1 heads out of 2 options here. So that's going to be a probability of 1/2. Now just remember, when we're multiplying fractions, we multiply across the numerator and we do 1 times 1 and we get 1. And then 6 times 2 is 12. And that's our answer right there, 1/12. How about this? What's the probability of spinning a white on this spinner right here? There's 2 options for white, as you can see. And then what's the probability of rolling an even right there? Well, let's focus on the probability of getting a white. Well, how many whites are there? There's 2 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's going to be a probability of 2 over 12. And of course, what you spin on this spinner in no way impacts what you're going to roll on your die. Okay, so what's the probability of getting an even number on a die? Well, you might immediately say 1/2, but if you don't, just note that you've got a 1, 2, 3, 4, 5, and 6. How many of them are even? Well, you've got 3 out of 6 that are even. Well, let's go ahead and reduce both of those fractions right away. This becomes a 1/6. Just made my 2 over 12 1/6. That's just reducing my fraction. And 3/6, of course, is just 1/2. Now this becomes just like our top problem where we do 1 times 1, multiply across the numerators, and we get 1. And 6 times 2, our denominators become 1/12. All right, last one before we move on. Where the heck am I? We've got the probability of, let's do flipping a tails, flipping a tails, flipping a tails, and then how about getting a 6 on a die? Well, what's the probability of getting a tails? That's 1/2. What's the probability of getting a tails? That's 1/2. What's the probability of getting a tails? That's 1/2. What's the probability of getting a 6 on a die? Well, that's just 1 out of 6. Multiply all the way across. 1 times 1 times 1 times 1 is 1. 2 times 2 times 2 times 6 gives me 48. So you've got a 1 in 48 chance of doing a tails and a tails and a tails and a 6. All right, it's much more likely to do the top 2 probabilities. All right, how about this one? And just know that on your test, you are welcome to have this picture out. Reference this picture during your test if you don't know your deck of cards. But what you should know is that there's 4 suits. There's the spades, there's the hearts, there's the diamonds, oopsie, and then there are the clubs. And within each of those suits, we have an ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, and king. And because of that, you can see that we have 4 of each card. For example, we have 4 aces, we have 4 2s, we have 4 3s, etc. However, note that there's only 1 ace of spades within the suit of spades. There's only going to be 1 ace. All right, now that we've kind of gone over that, let's do some probabilities here. Let's find the probability that you pick a 3 and then you pick a black card, and then you pick a jack of diamonds. Now you might be saying, hey, whoa, Miss Sorensen, hold on a second. Isn't this dependent probability? And I want you to make note that I would say on this problem very, very clearly, I would say this would be with replacement. Meaning, after you pick your first card, whatever you get, you're going to put it back in the deck. All right, we'll do a situation where we don't moving forward, but we're not quite there yet. All right, how many cards are there? Well, notice that there are 13 of these times 4, and 13 times 4 is going to give us 52 cards. So if I'm trying to find the probability of getting a 3, well, there's 4 3s out of 52. And again, remember, we picked that thing and then we're going to put that card back, at least for this problem. Now, what's the probability of getting a black? Well, you can see that we've got 13 that are black here, 13 that are black here, 13 that are red, and 13 that are red. So we've got 26 out of 52 that are black. Let's reduce that. That's definitely half of our cards are black. Okay. Now, what about the jack of diamonds? Well, how many jack of diamonds are there? There's just one. It's right here. There are 3 other jacks, but they're not the jack of diamond. So that's just going to be 1 card out of 52. So now let's multiply across our numerators. That's 4 times 1 times 1. That gives me 4. And then we multiply across our denominators, and that gives me 5408. You absolutely need to watch that video on reducing fractions. And after doing that, we get 1 over 1352. So a pretty low chance of picking out a 3, putting that card back, picking out a black, put that card back, and then picking out a jack of diamonds. All right, let's do a few more. So let's find the probability of spinning a consonant. It's a hard word to spell. On spinner 1, and then a 4 on a die, and then a black card. Now, just as a reminder, a vowel is the set of A, E, I, O, and U. And consonants are actually going to be everything not a vowel. So that's going to be V complement. So for example, here we've got a consonant, consonant, and a consonant. Here we have a consonant, 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 and a consonant. All right. All right, let's go ahead and do this. So first of all, what's the probability of getting a consonant on spinner 1? Well, that's 5 consonants. You can see my check marks are 1, 2, 3, 4, and 5. Out of how many letters on spinner 1? That's 8. Okay, now how about spinning a 4, not spinning, but rolling a 4 on a die? That's going to be 1 out of 6. There's only 1 4 on a die. And then what's the probability of picking a black card? Well, that's going to be 1/2. Half of our cards are black. So multiplying that across, I get 5 over 96. Which is as reduced as it gets. So we have a 5 in 96 chance of spinning a consonant on spinner 1, and then rolling a 4 on this die, and then getting a black card right here. And notice they are all independent probabilities because what you spin on spinner 1 does not impact the card that you pick or what you roll on your die. So in theory, we can calculate probability for independent events by just multiplying their probabilities across. But you got to make sure that they're independent events when you use this method.